नमस्कार दोस्तों, मैं हूं अभिजीत गुरु और स्वागत है आपका मेरे इस चैनल में जिसका नाम है केमिस्ट्री लर्नर्स। सो इन दिस लेक्चर वी आर गोइंग टू सी आयोनिक बॉन्डिंग। आयोनिक कंपाउंड्स क्या होते हैं और वो कैसे बनते हैं, ये हम इस लेक्चर में देखेंगे। इसमें हम जानकारी देखेंगे कि एक्चुअली आयोनिक बॉन्डिंग क्या होती है या फिर आयोनिक बॉन्ड क्या होता है, और दूसरा हम देखेंगे कि आयोनिक बॉन्ड या फिर आयोनिक मॉलिक्यूल्स कैसे बनते हैं, जैसे कि सोडियम क्लोराइड है या फिर कैल्शियम क्लोराइड है, ये मॉलिक्यूल्स कैसे बनते हैं ये हम इस लेक्चर में देखेंगे। Ionic bond, this is the bond which is formed by loss or gain of electrons, that is nothing but the ionic bond, and this ionic bond is also called as electrovalent bond. So if you see the examples, sodium chloride and calcium chloride are nothing but the examples of this ionic bond. This name itself indicates that the ionic bond is nothing but the bond which on dissolution forms ions. So there are ions which are associated with this particular bond. That's why this is nothing but the ionic bond. So there are two types of ions. One is cation and another one is anion. Cations are positively charged and these anions are negatively charged. So with the combination of particular cation and a particular anion, there is a formation of this ionic compound. So whatever this ionic compound is going to form, that is formed by ionic bond. So that compound is formed by loss or gain of electrons. Loss of electrons, which results in formation of cation, and gain of electrons is results in formation of anion. Okay, now the example, if you see the sodium chloride and calcium chloride, the question may arise is that the sodium chloride on dissolution form this Na plus and Cl minus ions. Why this Na plus is only formed? Why Na minus not? Okay, Na plus ही form होता है, Na minus क्यों नहीं हो सकता? This may be the question. Or vice versa, if you consider this chlorine, Cl minus is formed, but why this Cl plus is not going to form? So that answer is explained by the formation of such type of molecule. That is this ionic molecule, that is sodium chloride. Okay, so we'll proceed for the formation of this sodium chloride. So how this sodium chloride is formed, that we will see. Okay, so formation of sodium chloride. If you see this sodium chloride, there are two elements or two atoms are there. One is sodium and other is chlorine. For this particular formation of molecule, we have to consider the electronic configuration. Both electronic configuration means orbit electronic configuration and other is orbital electronic configuration. So this sodium, its atomic number is 11 and the chlorine having atomic number 17. That's why the electronic configuration of sodium is 1s2, 2s2, 2p, 6, 3s1. If you see here, in the last orbit there is one electron, and if I want to write the another electronic configuration, like this is nothing but the OR. Okay, so this is orbital electronic configuration which I have written here like 1s2, 2s2, 2p6, 3s1. But the another electronic configuration is, this is orbit electronic configuration, that is nothing but the 281. How it is 281? So this 2 comes from this first shell which contains 2 electrons. This 8 comes from here. This is the second shell. This 2 means second shell. Okay. So in second shell there are 8 electrons. 2 plus 6. 8 electrons are there. And in last orbit, this 1 electron is there. This is the third orbit in which 1 electron is there. Likewise, this comes as 281. This is the orbit electronic configuration, or electrons, arrangement of electrons in the particular orbits. Like KLM orbit, there is 2, 8 and 1 electron is present. Likewise, we can write the electronic configuration for this chlorine. How to write this? This is 1s2, 2s2, 2p6, 3s2, 3p5. If you count the electrons, 2 plus 2 plus 6 plus 2 plus 5, there are 17 electrons. Or the electronic configuration of orbit, or how the electrons are occupied in the particular orbits, that is nothing but the 2, 8 and 7. How? First orbit 2 electrons, second orbit 8 electrons, and this is the third orbit, 7 electrons are there. Okay, after writing this electronic configuration, one thing I want to tell you here, that the rule which is nothing but the octet rule, and the other rule is nothing but the duplet rule. So what is octet rule? It is the tendency of an element to complete its octet. Means in last orbit, suppose the last orbit is ns2 np6. In this orbit, suppose there are 6 electrons, 2 plus 6, 8 electrons are there. So this tendency to acquire 8 electrons in the last orbit is nothing but the octet rule. So according to this rule, every element tends to satisfy stability, or it tends to acquire the noble gas electronic configuration. You can say this is noble gas electronic configuration, because if you consider the elements, zero group elements, they have completed their octet, all the elements except helium. Okay, because helium completed its duplet. Then what is duplet rule? So duplet rule is nothing but the ns2. Means in the last orbit, or this is the first orbit only. Okay, if you consider this n is equal to 1, then this is the first orbit in which 2 electrons should be there. Then that element is said to be a stable element. Okay, so these are the two rules, that is octet rule and duplet rule. So after going to this, we'll again come towards the sodium. If you see this electronic configuration of sodium here, in last orbit there is 1 electron. Okay, in sodium last orbit only 1 electron is there. So to acquire the stability, means to acquire the octet, or to complete the 8 electrons, it needs 7 electrons. Okay, after accepting 7 electrons, it completes its octet. Or it may happens that it give this 1 electron. means minus 1 electron. So what is the easy thing that to be followed by this sodium? I can say that what is pervadable. Okay, this word may be new to you. So what is pervadable for this sodium? To accept 7 electrons or to donate 1 electron. Obviously, to donate 1 electron is a pervadable thing for this sodium. Okay, means this sodium can donate this last orbit electron, that is 1 electron. So what happens now if you see the next part of this formation of sodium chloride? So I just rough this here because in continuation with this I am just going to explain the next things. So sodium, okay, so sodium if donates 1 electron means this sodium is going to form a charge, that is sodium plus, and 1 electron is donated. So if you see the electronic configuration of sodium, it is 2, 8, 1, means 11 electrons are there. Okay, so this is 2, 8, 1, and if you see the sodium plus, what is the electronic configuration now? 2, 8, because last orbit which contains 1 electron is donated. So this is the 1 electron which is donated. Okay, similarly for chlorine, if I do this, so for chlorine, if I am using this another color, so here this chlorine, what is atomic number here? 17. So this chlorine, if you see the electronic configuration here, 287, same thing. This chlorine may accept 1 electron or it may give this 7 electrons. So what is the pervadable thing or easy thing for this chlorine? The easy thing is that to accept 1 electron to complete the octet, means in last orbit 8 electrons should be completed. For completion of these 8 electrons, it accepts the 1 electron. Okay. Therefore, if I write this statement for this chlorine to accept the electrons means 1 electron plus 1 electron. So it gives you chlorine and atomic number becomes 18. Okay. So what is the electronic configuration here? 2, 8, 7. And what is the electronic configuration here? 2, 8, 8. Understand? Now these have completed its octet and this sodium is also completed its octet. So after completing the octets, this chlorine forms the negative charge and this sodium forms the positive charge. What is the output or what you understand from this process? That there is a transfer of electrons from sodium to chlorine. Means if I write this statement in this way, that this sodium plus chlorine minus, this is going to form sodium chloride molecule. Okay, means there is a loss of electrons from the sodium and there is a gain of electrons from the chlorine. Okay, that's why the bond which is formed between this sodium and chlorine is nothing but the ionic bond, because as per the definition, what is the definition of ionic bond? The bond which is formed by loss or gain of electrons is called as ionic bond. So in this way we have explained here the formation of sodium chloride. Do you understand this? Okay, so we'll proceed for the next part, that is another example. Okay, we'll see now the another example in which one calcium atom is there and 2 chlorine atoms are there. Okay, so the calcium, atomic number of calcium is 20. Okay, so we'll see the formation of this calcium chloride. So if I take this next page, so formation of calcium chloride, CaCl2. Again the same process as I have followed in the previous page or the previous molecule. For sodium chloride, same process I am going to follow for this calcium chloride. Now see here, this calcium atomic number is 20 and there are two chlorine atoms. That's why I am writing these two chlorine atoms separately for your understanding. So here atomic number of chlorine is again 17. If you write electronic configuration of this calcium, it is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. Okay, and for chlorine, what is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p5. The same electronic configuration for the second chlorine atom is there. That's why it is 1s2, 2s2, 2p6, 3s2, 3p5. If I try to write the another electronic configuration for all these atoms, how to write for this calcium? First orbit contains 2 electrons, second orbit contains 8 electrons, third orbit contains again 8 electrons, and fourth orbit contains 2 electrons. This is the orbit electronic configuration. Okay, now chlorine, first orbit contains 2 electrons, second 8 electrons, and third 7 electrons. Same for this second chlorine atom, 2, 8 and 7. Now what are the things that is going to form the bond between this calcium and chlorine? Okay, if you see the calcium chlorine structure of calcium chloride, this calcium, this is the chlorine, and again one chlorine atom. Okay, so this calcium is in between and two chlorine atoms are joined with this or bonded with this calcium by ionic bonds. There are two ionic bonds. This is ionic bond and this is also ionic bond. So how these bonds are going to form, that we will see now. Now see here, this calcium, if I try to write the calcium, atomic number is 20. So if I work out for this calcium that to complete the octet, what is the thing for this calcium? That 2 electrons are there in last orbit. Okay, in last orbit 2 electrons are there. So there are two things. One, it may accept, okay, it may accept 6 electrons to complete the octet, or it may lose these 2 electrons. There are two things. So what is the easy thing for this calcium? That to lose the 2 electrons from the last orbit. Now this calcium loses 2 electrons from the fourth shell, that is the last orbit. Okay, so what happens now? This calcium donates. So if I follow this color here, donates 2 electrons. So this calcium becomes calcium 2 plus because 2 electrons are donated. These 2 electrons are lost. That's why calcium 2 plus plus 2 electrons. Okay, now what is the electronic configuration for this calcium? It is 2, 8, 8, 2. And for this calcium 2 plus, it becomes 2, 8, 8. So this have completed its octet. That's why this is stable now. Calcium 2 plus is stable as compared to this calcium because last 2 electrons are lost and it has completed its octet. Similarly, I work this for two chlorine atoms which are given over here. This is first chlorine, this is second chlorine. Both these chlorine atoms are having first and second, they are the same elements. That's why they are having same uh, uh, loss or gain of electrons, which is same for this both chlorine atoms. That's why this chlorine atomic number 17. Okay, so this chlorine accepts one electron, as we have already seen in the last example for sodium chloride. So it becomes chlorine minus, and number of electrons becomes 18. So what is the electronic configuration here? 2, 8, 7, and here 2, 8, 8. Do you understand this? Similarly, second chlorine molecule again follow the same thing, because both the chlorine atoms are same. Cl minus, here again it becomes 288 and it becomes 287. If you see the picture here, two electrons are lost by the calcium. Okay, and these two electrons, if I explain for this calcium chloride, one electron is abstracted by one chlorine and the another electron is abstracted by the another chlorine. That's why these two electrons are lost and gained by calcium and two chlorine atoms. That's why there is a formation of calcium chloride. So how to write this reaction now? So if I write this reaction here in this fashion, like this, calcium 2 plus two chlorine atoms are there, or ions, so that going to form CaCl2, that is calcium chloride. Understand? Overall there is a deal of two electrons, so it loses two electrons, loss of electrons takes place, and here gain of electrons takes place. That's why whatever the bond formed between this calcium and chlorine is nothing but the ionic bond. Okay, so this is nothing but the ionic bond. Understand with this? So we have seen two examples for ionic bonds, formation of ionic bonds. Okay, I think this is now clear to you how this ionic bond is going to form. These are the three elements. Triatomic molecule is there, and the previous NaCl we have seen the diatomic molecule. Okay, so this is the NaCl, it is diatomic molecule because two atoms are involved here, and in this calcium chloride triatomic molecule because three elements are involved here, or three atoms are involved here. Understand? So we conclude here. For such important and informative videos, please subscribe to my channel Chemistry Learners and don't forget to press bell icon button. Thank you.